Economists plot cost curves with quantity on the horizontal axis and dollars on the vertical axis. When we plot the marginal cost curve and the average total cost curve, we'll always have that the marginal cost curve intersects the average total cost curve at the minimum point on the average total cost curve. The reason for this is simple math. If the marginal cost of the next unit of output is less than the current average total cost, then average total cost will decrease when the firm produces the next unit. This is what happens to your average test score in a class when your score on a test is lower than the previous average. The lower test score pulls down your average. Because a lower marginal cost pulls down average total cost, the average total cost curve has a negative slope whenever marginal cost is less than average total cost. If the marginal cost of the next unit of output is greater than the current average total cost, then average total cost will increase when the firm produces the next unit. This is what happens to your average test score in a class. When your score on a test is higher than the previous average, the higher test score pulls up your average. Because a higher marginal cost pulls up average total cost, the average total cost curve has a positive slope whenever marginal cost is less than average total cost. If the marginal cost of the next unit of output is equal to the current average total cost, then the average total cost will not change when the firm produces the next unit. This is what happens when your average test score in a class equals the score on the next test. The test score does not affect your average because an equal marginal cost does not affect average total cost. The average total cost curve is flat, which means it has a slope of 0 whenever marginal cost is equal to average total cost. Since the curve is flat at its minimum, since the curve is flat at its minimum, marginal cost must equal average total cost at the quantity that minimizes average total cost. The graph below shows the relationship between marginal cost and average total cost. So the marginal cost curve intersects the average total cost curve at a quantity of about 5.5. When quantity is less than 5.5, marginal cost is less than average total cost, and the average total cost curve has a negative slope. When quantity is greater than 5.5, marginal cost is greater than average total cost, and the average total cost curve has a positive slope. At this point, where marginal cost equals average total cost, the average total cost curve has a slope of 0. Notice, when average total cost is at its minimum, the slope must equal 0. Now, marginal cost and average variable cost are connected. In the same manner, at marginal cost and average total cost are connected. The marginal cost curve intersects the average variable cost curve at the minimum point on the average variable cost curve. If the marginal cost of the next unit of output is less than the average variable cost, then the average variable cost will decrease when the firm produces the next unit. Because a lower marginal cost pulls down average variable cost, the average variable cost curve is a negative slope whenever marginal cost is less than average variable cost. This is exactly the same relationship that we described earlier when we talked about marginal cost and average total cost. I'm simply replacing average total cost with the words average variable cost. Number two, if the marginal cost of the next unit of output is greater than the current average variable cost, then the average variable cost will increase when the firm produces the next unit. Because a higher marginal cost pulls up average variable cost, the average variable cost curve has a positive slope whenever marginal cost is greater than average variable cost. If the marginal cost of the next unit of output is equal to the current average variable cost, then average variable cost will not change when the firm produces the next unit. Because an equal marginal cost does not affect average variable cost. The average variable cost curve is flat, which means the slope equals 0, whenever marginal cost is equal to average variable cost. Since the curve is flat at its minimum, marginal cost must equal average variable cost at the quantity that minimizes average variable cost. There's a little example. From the bar, you could get a mimosa. It's $12 for the first mimosa and 1 cent each. In this case, the average cost of the first mimosa is $12. The marginal cost of the second mimosa is 1 cent. What's going to happen to the average cost after you drink the second mimosa? Well, the average total cost will go from $12 to $6.50 if you buy two. And it'll fall to 12 divided by 0.2. It'll fall to $4.00 if you buy three. And it'll fall to $3.75 if you buy four. The reason the average cost is falling is because the marginal cost is always less than the average cost that you paid for the preceding units. Marginal cost and average product are connected. Marginal cost varies inversely with marginal product of the variable input. If marginal product increases when the firm increases employment, then marginal cost decreases as the firm increases output. When one goes up, the other goes down. If marginal product decreases when the firm increases employment of the variable input, then marginal cost increases as the firm increases output. If marginal product always decreases as employment decreases, if marginal product always decreases as employment increases, then the marginal cost curve always has a positive slope. The examples in ManQ typically use a marginal cost curve that always has a positive slope. If marginal product increases initially as employment increases and decreases at higher levels of employment, then marginal cost curve is U-shaped. In our example with the widgets, we typically had marginal product increasing between the first and second, maybe third unit of labor, but then marginal product began to fall as we went to the fourth and fifth units of labor. So in our widget example, we tended to have marginal product increasing and then decreasing after it reached a certain point, which means the marginal cost would decrease and then increase as output rose, which means the marginal cost curve would be a U-shaped curve. Time to look at and expand your understanding set of questions. I'll be back in a little bit.